Hello, Redshifters. Redshift 3517 introduces a new random generator, Jitter. Now, what this does is it replaces and expands the user data, if you want. Okay, so prior we had 5 user data nodes. I didn't add the fifth one, which is string user data, because that works only with OSL. But mainly, at least for C4D users, which uses presets here, like the object geometry ID color, this was a bit of an issue because C4D evaluates things a bit different when it's using geometry ID. And that's because when it evaluates the scene, depending on the evaluation mode, those return numbers are different. For instance, this is IPR in progressive or bucket mode. You see there's the same, but if I do a full render or render to PV, these numbers and these colors will be different. And that's a bit of a problem because you usually work in IPR, you don't work in full renders. Okay, and you don't want to set up your scene in different res and then just do all the time do full renders. That's not fun. But this is due to the fact that when we're doing IPR, the scene is from memory. When we're doing a full render, the scene is evaluating from scratch. It's like opening C4D again. Okay, and that C4D generates a new ID, and what it returns, it's a different color. The same thing happens for the scalar user data. As again, presets, object, geometry ID normalized. You can see here you have, sorry, the not the geometry ID. Geometry ID normalized. There you go. Okay, and when you're doing full renders, this value changes. Same thing for integer user data. If you're using geometry ID and you do a full render, you get something different, right? Now, this is not the case with Jitter. Jitter is absolutely reliable, and I'm going to show you in a sec how. But before doing that, we're gonna go back to color user data and show you a bit what we had before. So you could have a color, which MoGraph colors come from whatever color you're set for MoGraph. You can have object display and layer colors, which are from here. And as I said, MoGraph, that means I'm talking about this color. Okay. So if you choose something else like an index ratio, this is interesting because this gives you an ordered ID. So you get the differentiation, it's on the rows, the columns are identical in this case. So it depends on how the cloner is set. Of course, in this case, it's set as a grid. Okay, but you can have, I don't know, you can have something like a radial, and let's make the radius different. And you can see here you get a different color in, at least in this radial distribution. But probably a lot of time you're going to try to use something like a grid. In this case, it's how this internally generates a value, right? So the MoGraph ID ratio, it's, as you can see here, repeatable. Okay, and then you have geometry ID color, what we discussed already, and the color alpha and particles. And these are unreliable. The same thing happens in here with the scalar user data, where object ID normalized. In this case, it's a progression from 0 to 1 based on the object ID, internal ID. And this is again an ordered one, but it's not repeatable. It has its usage. Index ratio, which is like this one using a ratio, it's repeatable. And then you have the weight, if you set the weight in the cloner and things like this. I mean, I'm not going to discuss every one of these ones because you already know those from the documentation. Okay, but it's just that what you can can use. Sometimes, for instance, you can't see the values, but if you pass the value to a multiply node, for instance, you can see the values. Some nodes don't produce a proper output, if you want, on the display buffer, just because they're not supposed to. And if I put this to 1 here, you should see the values. Now you can see here 0, 1, 2, 3, blah, 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 up to 48. From 0 to 48, there are 49 total. You can see here, this is 21 as a value. And this is because there's a clamping on top of everything. And that's because you don't want to have fireflies and things like this. So if I go here to filter, increase this to 100, you're gonna see here 48. Okay, that's why you don't see the value by default. If you're pushing this data through an AOV, like a custom AOV, then you will see the exact value. But for some things, these values are a bit um, less than expected, just because of this clamping that only happens on the display, on the beauty, not on the AOVs. Okay, so this is what you're seeing with the integer user data. Again, it's 0, 1, 2, so blah, 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 for 48, right? Integers. For the vectors, you don't have much here that you can use. It's the only thing that's maybe interesting is this one, right? Where you have red and green and blue, right? And just the red and blue are variations. Again, the same kind of normalized ID variation. But other than that, size probably doesn't tell you much because you have nothing in the cloner that right now modifies the size. Now, the jitter node, on the other hand, it's based on a few things: name ID, object ID, and user data. For the object ID, it's something that you're gonna add. In C4D case, you add an object tag. In my just an object ID attribute. The same thing happens um, in Max and Houdini. Okay, and of course you can see this. You can vary this, right? In this case, the object ID is the same because this is a cloner, and it doesn't matter how the cloner is set up, instance or render instance. Okay, it shares the same ID, like I do this here or there. Now, you can of course vary this. I mean, you can have two cubes, right? Not two cloners, but two cubes, right? And one cube can have a different ID, and you get different things. Hey, let's put these three cubes, and these three cubes have a third. You can see that they're ordered, right? And that's probably because how the cloner operates in terms of um, iteration, as you can see here, iterate, right? They're not random. You can do a lot of things with the cloner internally, just because the generation of the IDs it's in a controllable way. By default, this is an iterate, not in random, which makes the whole um, integer user data here. You can see 0, 1, 2, and 248. Well, it's again 21 is the same issue, but this is no matter the randomness on and off, because it's iterate or not, you're still getting the same thing. Okay, so this can be interesting and flexible up to some point, depending how you want to use this. Okay, if you want to group objects, it's easier to set the same object ID and use the jitter node for that. Let me just delete these and recreate the jitter. The biggest question is, how do you use this, right? By default, when you're enabling it, it's based on the name. And you can see here, a strange thing will happen. I have two objects with the same name, they will get the same color. Although C4D is the only DCC that allows you to have the exact same name, because for the users, these are the name, but internally there's something different. There's a hash involved, and for instance, cloner under the cube here will be different than this cube, which is outside the cloner. And I can prove that by just increasing this. You can see these two are the same color. This is slightly different. They're all three called cube. This one is in a hierarchy, which even if the hierarchy is disabled, it's still there. Okay, so I don't know if internally we concatenate the name of the or flatten the hierarchy completely or not, but it depends on how your hierarchy is built to get this differentiation in the name ID. Okay, so this is not the most interesting part. The most interesting part is how to use them. Okay, and we've seen that we have maybe random, maybe ordered IDs, and this is completely random. And the question will be, how do I use it properly? Okay, well, one of the most common use is to put some textures on something. So let's go here and grab from my wonderful library of textures, which are like 10. We're gonna get something. Okay, so in this case, it's kind of a parquet tile, and every single one of these are the same. And of course, in the past, you were going to, let's say, scalar user data, and you're going here and say, hey, I want to offset this. Okay, and you're gonna get a slightly offset result. And you can see they're not identical, so or they shouldn't be identical. Let's see what this does. It's weight. Well, weight is 0, so there you go. Object ID normalized. So there's slightly, you can see this. This is like a progression where everything it's slightly offsetted one by one, and that's not fun, right? That's why you want something different. You want to use something like, in this case, if you want a float value, just to deal with, let's say, with rotation, you're gonna think, hey, I'm gonna put a float value here and go rotate and set the maximum float. In this case, say meaning maximum 0, I'm gonna put it to 360. And this is nice, it's interesting, it works for a texture that is not easily recognizable. In this case, this is easily recognizable. And the question is, how do I do with this to get some 90 degrees? Because all I want is 90, 90, 90, and so on and so forth, right? Well, instead of using a float, you're going to use an integer, right? And that integer will be 0 to 3. Why? Because we're going to multiply this by 90. We're going to have 0, 90 degrees, 180, and 270. Otherwise, well, the next one will be 360, which is equivalent to 0. But right now, you don't see much, right? So we're going to get ourselves a multiply, and we're going to multiply that value with 90. And you get this 90 degrees, which is an advantage and a disadvantage, because if you're trying to get something that's repeatable, but 90 degrees rotated, but randomly, just the rotation, but otherwise you're trying to get alternate results, well, the jitter won't give you that. Okay, you'll have to rely on something else. Let's see what we can do. We can do this. We can do index ratio. Okay, well, how about this? Let's try to do index ratio, and let's see what we get. Okay, well, that's not very fun, right? And it's not very fun because we're getting here 0, in this case will be 90, 90 something, and so on and so forth until we get here, which will be 360. So let's try 360 instead of 90. Okay, well, still this might be an interesting pattern, but maybe it's not what we want, right? Instead, we're gonna use, maybe instead of this one, we have, as I said, you have this one, which is different for each one, which will give you a slightly different rotation. And you can see here, you can kind of notice that this is an actual progression, right? It depends on how you put it in the shape, but it's something that you can use. You can also use the integer user data, right? Um, let's do this, and this will be again 90. And this is a bit more interesting because although these are um, rotated, right? You can see this is rotated in one way. It's still horizontal like this one, but they're different. This is maybe 180, this might be 0, or this is 90 and this is 270. It's a different feel from something completely random, like this one. This one shows kind of a mess, if you want. Okay, I did not know how to put these tiles. This one says, I know how to put these tiles and I varied them a bit. Okay, so it depends on how you're looking at things. If you're putting this to 2 and 2, okay, well, this might suck. Maybe this is better. I don't know. It depends on how you use it. There are things that are good in close up and things that are good um, when you're looking from far. Let's put this on 7. So for instance, I can see here it's a bit of a random thingy. Yeah, it doesn't bother me that much because I can see this is broken by this one and so on and so forth. If I use this one instead, I can see clearly this is a repetition that's, well, I don't see the fact that this is flipped compared to this one and so on and so forth. My eyes goes to a general pattern. This is easily recognizable while this is less. Okay, this might look more natural, although you tend to put these kind of tiles in your home or parquet, whatever you want to call it. Okay, so it depends on how you want to use it. Do you need an ordered ID? Yes, you can get an order ID with the user data, right? The presets. If you're in Maya Houdini Max, probably not Blender yet, but Maya Houdini and Max, you can do the same, but you have to script it. Okay, there are no presets for this, so you don't get the color ID and user color data and find these. No, these are specific for C4D. Okay, there are some presets like, for instance, Maya can use RGBPP if your particle instancer outputs RGBPP or opacity PP or things like this, user scalar 1 pp and user vector 1 pp, and from 1 to 5. It doesn't matter. It's just how you use this, right? Let's say you want to use this not 90 degrees, you want to use them, hey, I wanted 45 degrees, right? And you get something a bit different. But that's because the jitter has 3 outputs. It allows you to do things in a different way. Now, the next part of this is the user data. Now, the user data allows you to create your own user data. Well, kind of rely on these guys to randomize whatever inputs you have here into this. By default, this is uses the name ID and create some random numbers. Of course, you know how to use the seed and everything else, right? But in this case, um, even if I change this, it will change everything together, right? And if I change the user data, as you can see here, 1, 2, 3, 4, 5, and so on and so forth, right? And this changes. What you want to feed here is something that's unique or not per input for user data. In this case, I can use the integer user data, for instance, right? And feed something. And that something will go into, where's the user data? Sorry. There you go. Okay. You're not going to see any thing that's really big has changed because you remember this is from 0 to 49. Let's see if I can render it. Or sometimes it doesn't show up. I have to pass it through a mole. There you go. So from 0 to 48, again, it shows 21 because you know already why. But in this case, this kind of works, but if you're trying to use a scalar user data, right, which is using object ID normalize, which is, remember, from 0 to 1 instead of 0 to 48, right, 0 to 1, things will, of course, look different, right? So go here to user data, and you're wondering why the jitter looks kind of silly. It gives you just this. And if you're looking at the actual created values, it's like nothing. And you look at the mole, hey, okay, this is what? This is 21, 21, everything gets, oh, there's a, no, everything is 21, right? It's, which is a bit weird, but if you're looking at the whole result, it's a bit different, okay? And you can see some things are happening here, something are happening there. And that's because the scalar user data goes from 0 to 1 when this is actually expecting more. So we'll have to multiply this by some value. Not 1, of course. We want to put more values in there. Okay, and we're starting to have something. So 49, for instance. Okay, and these are a bit different. So you can use the jitter node to rotate things, to offset things. In this case, let's say I just want to have a kind of a standard approach with user data. This is, let's see, this is from 0 to whatever. I want a scalar user data. I'm going to multiply this by 3. Okay, so it will be from 0 to 3, 0, 1, 2, 3, which are 4 numbers. I'm going to multiply this by 90. Okay, and I'm getting this, which is to be expected. Okay, and the thing is, okay, I want these because these are a bit different. Maybe I want to offset the texture. I don't just want to rotate this. But let's say this is just the rotation, right? Which should give me some numbers. In this case, I don't want this to be 0 and 0 and 3. I think it works. I rather have the integer user data here. Okay, instead of that, just to get these tiles rotating. But the thing is, everything is, you can see it's flipped, right? It's either this or that. And I want a bit of variation on the, not necessarily the scale, but the offset, right? Now, for this, you're gonna have to use the texture offset here. Basically, you're going to go for float output and offset. This is fine, but it creates a 45-degree angle because you're going to end up with a vector that has the same value for x and y. In this case, the offset is a 2D vector, not a 3D vector. So what we're going to do is we're going to go for a vector maker. And if I only want to offset these on the x, I can do that, right? And that's because the y is 0. You can see here I can modify the y and you can see it moving around, okay? But it moves around the same way everywhere. So that means if I want a variation for this, how do I do about that? Well, you can create another jitter node, okay, which probably you could link with some expression, something you can link these values and just modify the seed. Okay, so we can see here, sorry, it should be out float, not color. Okay, you go for the float, and for the float seed, you say, hey, this is a slightly different one. Maybe I should use something like this. See how this differs. And you can do this for pretty much everything that you can use in here. I'm not saying necessarily that you, hey, for the 2D texture. To be honest, if you're trying to do this on a scale, it's a bit weird, let's say. Let's say you try to use scalar user data and put it on the or another jitter. Let's take another jitter and again float, put it on the scale. This will be a bit weird. It will give you really strange scales. In this case, or scale values, to be honest. Let's say this is 360. Well, a 360 repeat is really, really small, right? So you should, let's say this is between 1 and 2. And you have, or let's say 1 and 0.5, going the other way around. Okay, you can get interesting results without having to necessarily um, go berserk with the values, but you have to be careful on what you're doing with them. And although this is seems to be okay, it was 123 and then we go 124 and these seem like being small again, right? And that's because the values are somewhere in between and they seem to go for everything at the same time, right? Which can be a nice thing or not, but to be honest, one should be not the biggest in this case. I mean, I should the minimum should be smaller than the max. So let's do this the other way around. Okay, let's go for something like this. And this might seem a bit weird because if you're looking at the jitter right now and you have to look at the float by default in your soloing this is to show you the color, right? And not something else. But this is in user data mode. But user data is set to user data in this case is not set to name ID, which will create a different scale. That's why you didn't see it before, right? But these are, again, you can put the name ID and here instead of you relying on a user data because the user data will require you to create or either create or rely on something that exists already. But that's pretty much it. If you are varying this on a simple 2D texture or a 3D texture, like a Maxon, well, can you do that on a Maxon noise? That will be interesting. Let's see. I always wanted to vary the actual Maxon seed. That I know it's impossible, so that's not gonna happen. But let's increase a bit this and see how you can see it because this is in object mode by default, right? Not UV vertex or world. The world will give you this continuity before between them, but in object mode, and you want to make this a bit different, right? So let's say you want to do X and Y, and you go here and say offset. And it gives you a variation, right? You don't have to do much. I mean, to be honest, it's just two nodes. Okay, if you don't want this, you want to simplify it even more, you can go like this. Okay, but it's a 45 degrees. If you want something even more randomized, you can use colors, right? Which is a 3D vector. But again, it's not always fun. It depends on what you're doing. See, in this case, it's okay, you have red and you have green and the blue, which is XYZ, right? Blue, it's something different. So it depends on what you want to do with this. It can be fun up to a point. And for the maximum noise, I think it's a better thing to use a float than a color. It gives you something more interesting. Then the case of a triplanar, that's another case of having an extremely visible texture. And now I'm going to do the extreme and get the most hard texture to tile. Well, to vary. Tile. It's easy to tile it. I mean, there you go. Okay, now try to randomize this because you can't because these are in the corners. See, but yeah, it's something you can try to play with. Something like this. Okay, and then you think. In the past, we were used to put a max on noise on this, and this was like uh, offset, right? And hoping for the best here, and let's get a. I should get a vector multiply, not a mult, but you know what? Let's try. And there you go. And 1, 5. But again, this depends on the texture, because the texture itself, it's this. It's kind of weird. It's not the same. It's not a flat color on each object, right? So in this case, I have to go for something like this. And this doesn't look like much. I mean, you can put this to 1. Yeah, there you can see them. Maybe you can see them or not moving. I don't know. But there's clearly movement, and you can see it here, right? This is a really tough cookie uh, to break if you want, right? Because the nature of the texture, it's so that it's almost impossible not to tile it, or not to be visible. But as you can see, you can use the jitter in various ways. If you need a vector, you can get the color. If you need a color, you can get again the color, the float for 1D or 2D parameters. And if you need variation between for a 2D or 3D vector, then you can even use multiple jitters. But that's about it. Um, I hope you will enjoy this, because it makes the whole thing really easy. Basically, just use the name ID and don't create any user data unless you really need something that's ordered. Okay, and this will get you through. That's all there is, to be honest. It's extremely simple to set up and use. So I hope you're gonna have a lot of fun with it. Happy shooting. Cheers.